So Dennis, is there Dennis to be had?
Yes,
Dennis
I'm here.
Ruffer. All right.
I'm here. I'm here. I'm here twice. I'll be presenting from the other side.
Okay, introduce yourself when you're ready.
Yep, let me share screen. Let's do the whole screen just in case something comes up here. So, can you see my screen? Yes, you can. I can tell that you can see my screen because I have two sessions. So, I have not been talking. I'm Dennis Ruffer. Been around the fourth industry for way too long. And haven't been talking much recently because I've been diagnosed with myasthenia gravis. I've got a link for it in this blog. I'll pass the link to the blog over to Dave when we're done here. And there's been all sorts of life distractions. But the blog made it easy for me to throw something together very quickly here. I have gotten permission from my employer to talk. I can't say a lot on what I'm doing, but I can say a few things. I work for T-Mobile now. And even though I don't know much about the telecommunications industry, I have gotten, they need help on tiny IoT type stuff on little dinky devices. And they had a little dinky device going. You can probably still find the sync up pets on the web. And I didn't put a link for that because that was what we were doing. We're doing something different now. It's become a lot bigger, and T-Mobile has basically figured out that selling phones and phone equipment and that type of thing is not enough. That price is going to zero, as all of the consumables usually do. So they're working more on IoT. I just saw recently that they are the leader in 5G and IoT right now. So that's interesting, but I'm not sure I agree with it, but they at least have a head start on most everybody right now. In this project, we started out with something very different with the PETS project. That's where we started, and working on various very proprietary systems. And now, because we want to not have to make these devices, we are more in the idea that we want to set up somebody else so that they can make their own devices. And therefore, we went to something that was open source. And let me go over there. Oh, I'm already there. Am I? Yeah, there's just too much stuff on the screen. That's what's going on. Yeah, this thing up here on the top of the screen is in my way. How do I move it? I don't know if I can move it. Oh, there it goes. There it moved a little bit. So the Zephyr Project. The Zephyr Project is an interesting project in that it makes a real-time operating system and all of the support features that go along with it to make a system. And one of the things that I wanted to show is how many boards they support. They have a ton of boards that they support here under this project. This is the one that we are using right now, is the Pro Gecko Starter Kit from Silicon Labs. And it has a bunch of features, and then they tell you how to start it up. But I won't be showing much of that yet because we don't have it working yet. We have pieces of it working, but I certainly don't have what I'm talking about working. Where I will be using is they have a native POSIX version that you can run all of your stuff in Linux, as well as running it onto your hardware, which makes things very interesting. Makes you have a lot more choices. If you get stuck on your board, you can find another board or run it in Linux or do something else. You have a lot more paths to deal with. In that process, they've also got something in that they're getting public recognition, giving public recognition if you're contributing to their project. And I have contributed 2 things, and I'm working on a third. It is very likely that almost everything I do on this at the moment, I will be contributing up to Zephyr. We don't know what exactly we're going to do in the end product of what we're actually going to deliver to customers and where that one's going to go, but some portion of that will probably get contributed also. But they have set up this under Credly, a Zephyr Technical Contributor badge that I've gotten. And they've got a few other badges along there. I can probably go see what the other ones are. I go Zephyr. A maintainer, a contributor, a community contributor, and that type of thing. You all said it. So they've got quite a few things, and the badges are effectively part of Linux. They come out of the Linux group, which I thought was interesting also. But anyways, that's where what I got to, I could say publicly that I have that. They make an interesting way that they deal with all of these projects. They've had a lot of companies, and in fact, T-Mobile, just yesterday I heard that we have been accepted and paid our money to be part of the Zephyr project. The T-Mobile is part of it now. So getting them to accept a pull request, I haven't done that much in my career in contributing to an open source project, an official open source project. I realize that Forth is basically an open source project, but nothing near as big as what this one is. And it's been an interesting thing. Getting something accepted by them is an adventure. Dealing with people that you have no clue who they are or what their priorities are. But you have to go through them. A friend of mine that I worked with at Apple got me this job. And he promoted that I knew Forth and that I would do something with Forth. And I heard about it afterwards, and I said, wait a minute. Wasn't really intending on doing anything with Forth, but I guess I can if you twist my arm hard enough. And so that's what I've been doing in my copious spare time, which is I don't get a lot of. But my main job is working on the drivers for various IoT devices. On this board that we're working on, this is the Silicon Labs board that we're working with. And it was sort of existing before I started, but it was on different hardware. That was the sync up pets. And now we're expanding this to be much more inclusive to basically it's a package that will allow product developers to get into IoT and using 5G, our implementation of 5G. It's like most everything, you have to have software. And this is the software that we're working on. We went through a couple of iterations of different boards, and we ended up with this Pearl Gecko kit. And then we started out on Simplicity Studio. This is Simplicity Studio. It's an interesting development machine or integrated development environment. One of the most interesting features that they have here is you can actually design the chip based upon pins. And you just say what you want that pin function to be. And they have a bunch of software that can add it to those pins. And that was neat. That made programming. I've worked on some of those before. In fact, did a whole project based upon IDE. And they make life a whole bunch easier than having to reinvent from scratch. And so very simply, we created this system, and I can set up to go into that and compile that project. At least I think I was. Yeah, that's taking too long. Okay, so we're not going to talk about that much, but we will go over here, and what we've got here, this is the output of it, and this is the pets, and I can say help, and down here at the bottom, I have a ficl, and I can type ficl, and now I get an okay. Now, it doesn't actually work behind it. And in fact, it's being real slow about doing anything right now. Oh yeah, that's right. It won't, because nothing I type will actually come out. So that didn't make it very far. We didn't get very far on that implementation. But it was a start. That's where I started. And that's a little easier to see of that's what happened when I hit help, is this was the bottom. This is, we have a command shell effectively, or a command line there in among all the debug messages going by, which wasn't very user-friendly, but it helped us. But it was all proprietary. All of that stuff was proprietary, so I can't even really tell you how I did it. With Zephyr, I have the advantage of it being open source. And with their native POSIX interface, it is fairly simple for me to set up a system as I did here. And now I'll switch over to my, I use VNC viewer to log into my Linux computers so that I don't have to put up with a Linux computer for my daily life, which I hate. So, but here is the project, and very simply, the build's not going to do something. Let's do ARM -RF build so that the build actually does something, and it will. And I'm building there. The ficl is basically all that I'm building. It has a bunch of extra code that has wrappers around everything. And it gets a few warnings out of here, out of ficl still. And then it creates this Zephyr ELF project. But I'm not going to execute the ELF in this case because I'm building. I go back up here and show what my command line actually was. I should have. Yes, we did native POSIX and then gave a path to where my ficl is set up at. And that means that it's going to build that project. And now we're going to execute it. And that's all it did. And it is there now. It's actually running. I can point out that that is still the Linux console it's outputting to, which isn't the right thing to do. I actually need to switch that over to the serial port. But it's a good initial start. Now, back to the talk. Getting that running required something that I had over here, and let me, using static libraries is this is something that I found on the web, and I basically needed this little piece. This is the piece that I needed to have. And what I ended up changing that to is this. That allowed me to define what sources of all the C libraries inside the SRC directory, where this is, the SRC is a subset, or I can probably go show you that. I've still got a little bit of time here. Yes. So Zephyr Project. And inside here is ficl. That's what I pointed to. And this cmake list.txt is what I was describing, is what this is. This is my cmake list.txt file. So the directory underneath it is the source. All of this, I'm going to compile all of the C files there. And then I'm also going to, inside a ficl platform, pick up, seeing that I have the advantage of a POSIX system within Zephyr. I can target this as a Unix system. It's close. I have to get rid of a few things, like I don't have a file interface at the moment, but at least I can get things started to get in. And then soft core is the basic core of ficl. There's a bunch of that I have to go back and get at. I also found out that between the Simplicity Studio one and the Zephyr one, I have two different versions. that are both called the same thing. So I'm going to have to feed back some of my stuff back to ficl itself to clean up what they've got. And then figure out what I have to do to apply this to Zephyr and to submit this to Zephyr. That's going to be the most interesting part of this exercise, is how they take it, which will be, I have no clue. But anyways, I think that's about all I've got. That's all I've got written here. Thanks for listening. More is yet to come, but Kevin wanted me to fill some time, so I filled some time. And any questions?
Yeah, I have a question.
You did lots more than fill some time, Dennis, and now you're going to be done with requests for follow-on presentations and updates from me. That'll teach you. Thank you so much, Dennis, on with the questions.
Hey, I have a question. Have you considered using this for something like querying all the devices on a board? I know open firmware lets you print out the PCI tree, for instance, and obviously.
I actually worked on that. I did open firmware for 12 years, and so that is a thought. But that was done in the bootloader in order to create a device list of, or a device tree, basically, so that the Linux kernel didn't actually have to go and find devices. In a general purpose computer where you have the ability to plug in boards with new devices and to change on the fly at runtime, that makes a lot of sense. For an embedded device, and here we are talking about a deeply embedded device, for an IoT device, that is not appropriate anymore. You need to actually do these at compile time. And I actually did some of that when I was working on open firmware. We ended up with too big of a library to put into the boot ROM. So I had to select devices at compile time, as this system is doing now. I'm selecting devices at compile time rather than runtime. So that's a few generations ago that was needed. And I don't know, even the one laptop per child has died. I don't know. I think I hear occasionally that IBM is still using open firmware, but that's deeply buried inside of IBM. I don't know of anybody using it on a general purpose computer anymore for discovering devices. So I'm not worried about discovering devices. I'm worried about diagnosing devices and diagnosing at production line, where the open firmware the work that I was doing at Apple was very much directed towards the manufacturing line, and doing that diagnosis and testing that the system works in an extensible environment. And that's where I'm going at, is allowing something to be extensible in a diagnostic environment. Okay?
Thank you very much. That's very interesting. I'd like to correspond with you offline about it.
Sure. My information is all over the place. I'm daruffer@gmail.com.
Thank you.
Yep.
You should get T-Mobile to go straight forth. They'll make cheaper IoT with more intelligence.
Will it? I'm not convinced of that. There is way too much code. Take, for example, Zephyr itself. That is a ton of code that is designed to run on embedded devices that somebody has taken the time to debug and write tests for. Why do I need to reinvent that?
So when we started the project at Made in Space, we actually looked at, they had me look at Zephyr, and I went on GitHub, and there was over 1,000 issues.
Well, of course there are. Of course there are over 1,000 issues. You don't think there are over 1,000 issues in open firmware? That was on the market for decades? Our list never emptied. Our list of bugs never emptied.
Yeah,
and that's been my experience throughout my career, is the bugs never go away.
on embed systems, I'm really not a fan of time slice multitasking. Really not. You can usually break down a problem. I'm going to be in my talk talking about multitasking, so it's a little different approach.
And which, are you ready to go, Don?
Am I done? I'm probably out of time.
You're nearly done.
Good.
If you have one more question, or if you wanted to respond.
Yeah, I would just like to ask a question just so I understand.
Sure.
So the Zephyr, so this is a real-time operating system that if I have a Raspberry Pi Pico, which is an ARM Cortex-M processor, or I could load this RTOS on it, and there'll be, if your code is accepted, a fourth command line interface to it, effectively?
That's my idea. When I get there is a whole nother question.
Okay. No, thank you.
Yeah, but I'm hoping that I can have, they right now have Python in it. There is Python there. I don't know if they actually run Python in the product itself, but that's what I will be doing with Fork, yes.
Do you think you'd be able to interface to the Python, somehow have Python read parameters off the fourth stack and return values to fourth on the?
That is effectively what ficl does with C. ficl is a C-based fourth. And it allows you to call C libraries, C functions. You
Very
can call,
well, Python is C-based, at least versions of it. So yeah, that sounds very powerful to me.
right. It is in effect, and it allows me to, I can call fourth routine, ficl routines from within C, and I can call C within ficl. So I can go both ways. What I can do, I don't know what they have done with Python and whether it's in the runtime for sure. I don't know what they've done with that, but technically, yes, it's just another language.
All right.
Thank you.
Okay.
Thank you, Dennis.
Yeah, thank you.
I'd like to remind folks to mute their mics if they're not actually talking. Daddy's iPhone. Who's Daddy's iPhone? All right. Anyway, I encourage you to mute. And with that, on to Don, who should unmute.
Unmuted. I don't know if Bill's out there, but I took his advice. I have a black background now. See if you guys like it.
I do. Thank you.
Let's see. Oh, somebody's sharing says. Somebody needs to turn off sharing, it says. Oh, there it goes. Never mind. Let's see. Okay, can you see the presentation?
We can see your slide.
Okay.
CISC on risk engine.
All right. Yeah, it's kind of interesting. I had written a fourth in VHDL quite a long time ago. I met Dimitri on the fourth 2020 group. He does system Verilog. Basically, he's writing test benches and that sort of thing, testing RISC-V, and he's a guru in system Verilog. We switched to system Verilog at work, and I really liked it. I read a couple of books on it, and I was going to switch all my HDL to system Verilog. And I put my my VHDL up there. Oh,
Anybody have Don's phone number?
Give him a minute. While we're waiting for Don to rejoin us, I'd like to again remind you that we're looking for money to re-up on Meetup and to support the storage, at least for a time longer, and the eventual recycling of the Mountain View Press stuff. So contact me at forther@gas.net or through Meetup, or however you choose. My actual cell phone number and text message number are available in the internet if you look carefully.
Kevin, Green Rays is a 501c3 nonprofit, which is known as PolyScience, would be delighted to contribute to that. Any money that is contributed to PolyScience for that purpose. And PolyScience is 501c3, so you can write off your contributions that way.
I don't know that we're strictly speaking eligible to receive 503c donations.
Yes, sure.
Thank you for the thought.
Sure. Our charter is to promote Chuck's programming methods. Any repository of information that is beneficial to that surface is absolutely eligible.
That's very interesting. Could I impose upon you to drop me a line at forther@comcast.net and
Happy to do
describe that? And we
Way to
can
sort of not
have a-
launder the money, but certainly cleanse it of taxes for you.
Great.